Hello and good afternoon to those joining us in Europe, and good morning to anybody who's joining us from the east coast of the United States. I'm guessing everybody else is in bed. My name's Jamie Dobson, and I'll be joined today by my colleague Anne Curry. You may notice that we've started dead on time, and what that means is there's a few stragglers coming in to the webinar as we speak. So what I'm going to do, or what we're going to do, is just hang about for a few minutes while everybody logs in. In the meantime, some house rules and some etiquette for doing webinars. The first one is testing the audio. So what I'm about to do now is ping a chat to everybody and basically ask, can you hear me? If one of you wonderful participants would like to reply, if you can hear me, that would be really useful for me. The other thing, you may ask questions at any point during the webinar. Myself or Anne, depending on who's talking, will be monitoring the questions, and we'll either answer them if they're clarification questions during the webinar, or we'll answer them at the end. We'll keep a list and we'll answer them at the back end of that. Finally, as the webinar continues, we've got a number of handouts, and we'll distribute them to you. And if you're not around at the end of the hangout, then you'll get sent those handouts in an email follow-up. Anne, can you just confirm that you can hear me and that you can see my presentation in full screen?
Yes, I can hear you and I can see your presentation.
Would you want to say hello to everybody on the webinar?
Hi, folk.
Okay, right. Shall we get started on?
Yeah. Or we can chat, or we can for another few minutes let me learn. But I'm quite happy to get started. We're only doing beginning bits, just us introducing ourselves anyway. So if we missed that, it would be the end of the world.
Fair enough. Okay, so yeah, welcome to this webinar, everybody. So this is called Everything You Wanted to Know About Cloud Native But You Were Afraid to Ask. Some of you may have noticed that Anne and I spent quite a bit of time looking into cloud native technologies, different strategies, and that's what we'll be talking about today. Before we go too much further, I always forget to mention what on earth it is that Container Solutions do and who we are. So primarily we're a professional service company. Now what that really means is consulting, and consulting is typically broken up into implementation, the design of cloud infrastructure, the migration of applications, and of course learning and education, which is something we take an active part in. It's fair to say that our customers are mainly interested in rapid development. How do we shorten time to market? How do we respond to shifts in the industry, customer insights? The way we help customers achieve that is by containerizing their workloads and applications, which help us get the most out of cloud infrastructure. And it's those two, the combination of those two things, plus rapid development processes and practices, that sort of help us to create value for our customers. So I am Jamie, I'm the CEO of Container Solutions, I'm also the co-founder. I've been messing about with distributed systems for a pretty long time now, 20 odd years. And more recently, I've been taking care of the business development side of things at Container Solutions. We're about 3 years old, and I'm personally based in England. And if you want to abuse me on Twitter, Jamie Dobson is my Twitter handle. And Anne, I'll let you introduce yourself now.
So my name is Anne Curry. I've been in the industry for well over 20 years, so I like to call myself an industry veteran. I've worked on a huge number of different products, both for vendors and for enterprises, mostly distributed systems products. And I'm also based in London, and I'm also available on Twitter if anybody wants to chat about anything. So Jamie, back to you.
Thank you, Anne. Cheers. I was just checking. I've got a spy in the webinar who helps me to check the audio, and he's confirming that both of our audio is coming through loud and clear. So that's good. Okay. So then, what are we going to do? So we're going to do a quick introduction, because not everybody actually knows what cloud native technologies are, or what cloud native is, or the ones who do know sort of disagree with the other ones who think that they also know. So we're going to start by giving our definition. We're then going to look at some key observations before wrapping up with a case study on some of our conclusions. So what are these three key observations that we've made, either as our work as practitioners in industry or during the research for Anne's book, The Cloud Native Attitude? The first big one is that the companies we've observed who are succeeding with cloud native are the ones who have been migrating from monoliths to microservices. We think that this is true of the unicorns, Netflix and Google, but we also think it's true of, let's say, normal high street companies like ING Bank in the Netherlands, Holiday Check in Germany, and for example, Adidas in Germany, Bank of America on the East Coast. The other thing that we've noticed is organizations favor developer productivity over machine productivity. So even though migrations to the cloud might start as cost-cutting exercises or as a way to look at high utilization of compute resource, actually once the transformation's occurred, what they really value the most is how quick developers can move and how they can reduce their time to market and their time to value. The third key observation we've made is that cloud native is easy to get started with, but it's difficult to finish, and actually it's also easy to get into trouble with. Now we capture this observation in a model we call the cloud native journey, which we're going to look at, but first I'm going to hand back to Anne because she's going to explain what exactly is it that cloud native is.
Yeah, great. Jamie, if you step onto the next slide. And I've now lost all your... Oh, there we go. There we go. Right. Cloud native is a really terrible name because it spans an awful lot of different concepts. If you go to and look on the website of the CNCF, the Cloud Native Computing Foundation, they define cloud native as containerized applications, dynamically managed, and microservices architected, basically, or microservice-like architected. But I hate that definition. So when they're in dynamically managed, I think that what they're saying is orchestrated and also automated with scripts. But I hate this definition because it's all about how. What technology would you use for a cloud native approach? But it's not about why. And I know that cloud native is cool and all that kind of stuff, but but being cool is not a sufficient why for me, because this is a really difficult technique. There's a lot of investment, there's a lot of training, there's a lot of learning to be done, and I don't think it being cool is sufficient reason to do all of that. So when we were looking at the book, we were much more interested in the why. You know, it's great, cool technology, but why are people doing it? Jamie, do you want to step forward? Excellent. And I think, interestingly, there are three potential reasons why you might use cloud native. And in fact, that's one of the things that makes it complicated. There are lots of reasons why you might use cloud native. It does some quite amazing things, and it genuinely will do all of these things. But all of them require you to approach it in a different way and architect slightly differently. So one thing you could do with it is use it for scale and resilience. And I think that's what folk like, well, I know that's what folk like, the big hyperscale companies like Netflix, Google, are using this approach to give themselves more scale, so better response times to more users in more geographic locations whilst maintaining an excellent SLA. That's one good reason for using cloud native. Another is reducing operational costs, reducing your hosting costs, and certainly that's a big factor in the decision to go to cloud native for these big hyperscale companies. But there's also a completely different use case for these cloud native technologies, which is faster feature velocity, making your development teams more productive and get functionality to market more quickly. Do you want to step forward again, Jamie? Excellent, thank you very much. So what we found is that different companies have different motivations and they are using cloud native in different ways. But it's quite hard to do any of those things, and it's very important for anybody starting out to pick the one that they care about. And we are finding that unless you're hyperscale, and let's face it, if you're hyperscale, you've already done this. You started doing this 15 years ago. You probably missed monoliths entirely and just kept moving it along this line from distributed systems. If you're not hyperscale, then, well, a lot of your reasons for doing this stuff might be quite different, and that's what we're going to talk about later. But fundamentally, pick a goal. Have a motivation, pick a goal, and stick with it. And bear that in mind while you're making your architectural decisions. We'll talk more about that in a little bit, but I'm now going to hand over to Jamie for a little bit of the classics.
Yes, a little. So, yeah, so Anne did indeed mention the classics because part of this section is going to dip into Greek mythology. So Anne rightly pointed out that a lot of the direction your cloud native transformation will take will depend on what it is you're trying to achieve. And you would not believe how many people start dabbling with cloud technologies and even migration without fully understanding what it is that they're trying to do. So if you'll bear with me for about 5 minutes, we're going to cast our minds back to when we were teenagers. And for those of us who were fortunate enough to study any literature, you may remember a story archetype that was known as the hero's journey. Now, in Victorian times, people started to observe creation myths from tribes from around the world, but also some of our own creation myths here in the West. And it turns out that there was an interesting and maybe alarming structure to these different stories. And the stories themselves would start with this compelling call to action. The hero would be in a desert somewhere. For example, Luke Skywalker. He'd be fed up, kicking the tires of his hot rod, and he would feel this compelling call to adventure. Now, very often at the beginning of the journey, the hero is given a supernatural aid. This is either a magical power or a magical tool. Typically, before the hero leaves the overworld and enters the underworld, somebody tries to stop them. This was known as the Threshold Guardian. My favourite story, or my favourite hero's journey, comes from Greek myths, Perseus. So Perseus was given a shield, he was given a bag to put Medusa's head in, magic wings and a flying horse. And Perseus thought he knew what the challenge was, which was to go and kill the Medusa. And he had the tools, the supernatural aids to do it. Now, once the journey began, he sort of quickly bested Medusa, showed her a reflection in the shield. It was only then that the true nature of the challenge became apparent to him, which was that he had to fight the Kraken. Now, clearly, Poseidon was pissed off about something, and he unleashed the Kraken, on Athens, I think, and Perseus had to defeat him. And the two things he needed for that was ingenuity and courage. And it's interesting because this gives us an archetype for thinking about the cloud-native journey. The call to adventure, typically, or traditionally, has always been about, we have to get these systems under control. Things never deploy as quickly as they do. There's too much defects in the systems we are producing. However, since this was the status quo, the urgency to make these changes wasn't always apparent. In the last 4 to 6 years, very normal companies, some of them I've mentioned already, ING Bank here in the Netherlands, over in London, or over in the UK, in Edinburgh, Skyscanner, ASOS, the fashion house, Fashion Trade the Financial Times in London, Fashion Trade here in Amsterdam. Very normal companies have been really succeeding with cloud-native technologies, and they've been talking about that. So you have their competitors thinking, well, our systems are slow, our time to value is too long, and worse than that, if those guys can do it, why can't we? So in a sense, the call to action has now been compounded by a sort of cloud envy and the sort of, malaise that people feel because they have a sort of inkling that something could be better. They feel this call to action. Now, the supernatural aids of nowadays are Docker and Kubernetes, but also the hyperscale providers themselves, so Google, AWS, Azure. It's fair to say we have never ever seen tools like this in our time in industry. Now, it makes sense, doesn't it, that as time passes, our tools get better and better. We build on the innovations and the actions of the ones who come before us. So every year things get better and better and better. AWS is a classic example, really easy to get started with, but really easy to get in a mess with. The question is, why? What happens? So my colleague Pinny and the CTO of Container Solutions made a very interesting observation. So out there, when we visit our customers, and to be fair, a lot of them call us when they're in trouble, we find people that have, experimented with one container. They may have deployed it onto one of the hyperscale cloud, onto Google's container engine, or they've got into stage 2 where they've done a small application with a handful of microservices and they've used Docker Compose, or they've used Swarm to orchestrate them and actually think, yeah, this is an architectural pattern that works for us. It's at this point in the hero's journey some threshold guardian has to say, stop, don't go any further. You're about to be, you're about to enter the path to hell. That is not happening anymore. Those threshold guardians have been removed, and what's happening is we're getting full approval by management for transitions and migrations to the cloud based on a very weak understanding of the complexity of distributed systems. This is the point of no return. Once the KPIs are set and the plans are made, it's very difficult for an organisation to turn back from that. Usually, there's stage 3, the large production system moment, and this is when people start to panic. Now, this is often when people call container solutions. We'd prefer it if they called us earlier so we could help them to avoid these classic mistakes. So, why do they make this classic mistake? Well, if you look here, you see the evolution from architecture. We start with spaghetti code. That's what I did on my Commodore 64. And as we moved to the age of the internet, we started to realize that actually a tightly coupled monolith is one way to serve hundreds and thousands, and later hundreds of thousands of requests. Clearly, the limits of this architectural pattern were reached at one point, and people started to think about breaking up their monoliths into a collection of client-server applications, each application serving a different user need. So customers see this, organizations see this, and they think, hey, that's us. We went from spaghetti in the 90s, we had our tightly coupled monolith, we've been chipping away at that, we are ready for microservices. This is the error, because actually, if you move forward and look at the whole context of cloud-native technologies, you see that the picture is much, much broader. Now, I'm not going to go into everything on this model in depth, but I am going to start by mentioning culture. What is the build point of microservices? What is the organizational and managerial point of microservices? The point is to pull a collaborative, internet-based method of software delivery within your own firewall, within your organizational boundaries. What do I mean by that? Well, in the internet, we have federated data. So my name appears in many databases. It appears in Netflix's, it appears in Google's, and each of those organizations take care of their database. That's federation. What that means is that the same data appears in different places. That data is connected to an application or collection of services. If the services are open source, or if some of the products are open source, we can communicate back to those teams with pull requests on a Git repository. And then you've got things like GitHub, which allows you to create a shared memory for a project. So the reason why software development is done so well in the open source community is partially because of its collaborative nature. Any manager, any savvy manager will tell you the real reason for doing microservices is to take advantage of this really organizational and collaborative method of development. So how on earth can we move to microservices if we're still doing predictive or even iterative management and control? Well, it won't happen. Now, the other thing, of course, is delivery and infrastructure. Everybody that we meet who tells us they're doing fully automated continuous integration is usually either liberal with the truth or just lying. Now, it's not that they mean to lie, it's just that what they mean is that their automated build is almost fully automated, but there's just a couple of steps where a couple of people push a couple of buttons. That's fine, right? If you've got a 2-week release cycle and you can release your software in 1 hour with 1 button push, that's great. But as soon as you start to use microservices, you go to 5 to 10 to 20 to 25, you cannot push 25 buttons on a daily basis because the 1 hour that it took to deploy your monolith becomes 25 hours to develop your whole microservices stack. So very often we come across this pattern, the dogleg, where organizations are very close architecturally to microservices, but actually they're miles away when it comes to build automation and culture. And without containerized microservices that are continually integrated, it's extremely difficult to take advantage of the features of the cloud, such as automatic scaling, load balancing, and recovery from failure. So if you don't have all these things in place, you can indeed have a cloud, and it's going to be expensive, I can promise that, but you're not going to take full advantage of it. That is why people are struggling once they pass the point of no return. Now, Anne's going to talk about this later, but the companies she studied, the Financial Times, ASOS and Skyscanner, they realized very quickly this is not a technological problem. This is us not understanding exactly what's going on, and actually we need to confront this. So the companies that deal with reality and are happy with reality, they're the ones who move through the cloud journey quickly. It's the ones that are in denial that tend to fight and bicker for, in some cases, an indefinite period. So we pass out the back of the cloud native journey. The transformation occurs. There's often a period of atonement. Okay, that was a bit scary, but we're back now. We're back, and our new paradigm for coding and deploying and managing our infrastructure is here. And that is what we would think of as cloud native. What's going on? Why? Why now? So I mentioned earlier the call to action has been compounded by cloud envy. Organizations see other companies doing it and they think we want to do this too. It's not a bad thing. Supernatural aids. We've never had so much power as we have now. All free, all open source, and all very, very well documented. Now the question is, where did the threshold guardians go? Because when I was 25, which is about 15 years ago, we couldn't download things without filling in a form. And that continued, into the last 8, 9, 10 years. Who are stopping the developers doing whatever it is that they want to do? And how did developers and organizations get so much power? So this came from 2 areas. So the first thing is the move fast and break things idea. Spotify, Netflix, Facebook, they all championed this. And if I'm going to give my honest opinion, I think they were right. You cannot learn in a complex environment unless you take actions. So you learn by experimentation, and so a lot of organizations have removed the constraints for developers, and we've created what we call COEs, cultures of experimentation. So the way we've shifted to hyperscale and web apps is by actually removing the threshold guardians. But funnily enough, Mark Zuckerberg said last year, we want to move fast, but we want to break less things. And actually, that's what's happened in our organizations. They were all moving really quickly, and now they've started the journey. It's like, oh my God, everything's broken. Now, the other reason, the third reason, is the category growth. There's been an enormous, and I mean an eye-watering amount of money has been spent on engineering and marketing. The engineering effort's gone into the cloud providers themselves and the tools such as Docker and Kubernetes, and the marketing has gone into documentation, online tutorials, conferences, knowledge sharing. I've never seen a category or a segment of our industry so well done and so nurtured. But what does that mean, of course, is that everybody wants to get into this. And sometimes they go a little bit too quick. So Anne made a good observation this week. She said, cloud native looks like a can opener. Very useful, very easy to get started with, but it's actually more like a car. You have to learn how to use it. You can definitely put it in first gear and move down the road, but my goodness, that doesn't mean you're ready to race around Brands Hatch. And in fact, in doing so, you might actually kill yourself. And so an understanding, on the one hand, the vendors and the people growing the category position cloud native as like a can opener, but the truth is, which anybody who's studied distributed systems will know, is it's much more like an automobile. So that was the first key observation. Easy to get started with, difficult to finish. Now, the other key observation, which I'm going to hand over to Anne to explain, is how companies are succeeding by actually migrating to microservices.
Oh, thanks, Jamie. Canopy versus car. I don't know if any of you are old enough to remember that about 15 years ago, at the beginning of the 2000s, there was we used to have a lot of discussions in tech about we'd only just come to the realization that there was a concept of usability when it came to applications, and one of the first things that we concluded was that applications were generally either usable or learnable, and it was very important that you knew which of your applications, whether your application was usable or learnable. So usable is like a can opener, you pick it up and you can just use it straight away. Learnable is like a car, you can do more with it, but you can't just step in and drive away. And if you knew what your application was, you could design its UI better. So if it was a usable application, you wanted people to actually just be able to pick it up and use it. And of course, the interesting thing in cloud native technologies is that we do have a bit of a mixture. That Docker achieved popularity because it's actually a very usable piece of technology. You can pick it up, start using it, do useful things with it almost immediately. But the trouble is that the other parts of the technology, microservices and orchestrators, are not usable in that same way. They are actually really quite hard. They require considerable effort of learning. And if you go straight from Docker and seeing things as usable to Kubernetes or microservices and kind of just feeling your way with those, then you can easily get into trouble. And of course, the vendors kind of want you to do that because they get adoption by people just trying it out and getting started. But it can be a little bit misleading. So that's one thing that's quite misleading in our sector at the moment. The other is the talk of microservices just coming in and taking over, and everybody will want microservices, everything will be microservices. The dirty secret of technology is that right now most companies who are thinking about cloud native are not these hyperscale folk like Netflix or Google. They've done their own thing. It's ordinary folk, it's normal companies like the FT who built their companies up maybe over the past 10, 15 years, and they've built their companies up using monoliths. Because, do you want to step forward, Jamie?
Oh yeah, sorry.
Because the thing is that monoliths work very well. They're a really effective architecture, and they've been a very easy way of us moving forward for the past 10 years. So companies that are successful now and actually have the money to invest and spend on upgrading their technology often have a monolith, and the monolith is what's bringing in the money for them. So oddly enough, they don't necessarily want to chuck that monolith out the window and rewrite everything from scratch, because we all know that is a really quite dangerous thing to do. And one of the points of moving to the cloud and moving to a more iterative model is that you're no longer doing giant, big bang, dangerous projects, and rewriting your monolith is definitely a giant, big bang, dangerous project. But so the interesting thing when I've been going out and speaking to people is that generally they are not immediately throwing their monolith out the window. James, do you want to step on again?
Yeah.
Thanks. And I can tell you lots of anecdotal stories, but I hate to tell anecdotal stories. I think it's much better if we can look at some larger scale data. So this is a UK and Dutch hosting company called Cloud66, who do hosted containerized workloads, and they shared some of their data with me about how their customers, and they've got about 500, maybe a few more customers than that, who are running a containerized workload with them. And looking at that, they find that most of their customers have just lifted and shifted. They have a containerized monolith that they're just running on their container platform. So absolutely bog standard, they're still running their monolith. This is data from January 2017. About 30% of their people have just taken their monolith and broken it into two. So they've got a front end and a back end. So again, they're just migrating their monolith, they're not throwing it out. About 20% have progressed to the next stage. They've split some of those services into something a bit smaller. They're starting to carve off microservices that maybe contain functionality that's changing more quickly for them, and retaining the functionality that isn't changing that much within the monolith. So that's 90% of the people who are hosting with these guys, and these are fairly forward-looking, obviously fairly forward-looking companies because they're already hosting in the cloud and they're already using containers. Still, 90% of them are based still on their monolith. Only 10% have just started from scratch with microservices, and I think that's really quite interesting because it matches what I'm seeing anecdotally. It matches what's happening when I go out and chat to people about what they're up to. But this is genuine, slightly more statistically significant data. So, Jamie, back to you.
Thanks, Anne. Actually, before we go forward, I wanted to ask you a question. Do you think, so if you go to conferences and if you read blogs, if you follow the news stack, you get the feeling that everybody is doing containerized microservices on a hyperscale provider. But do we think that that 10% would hold across the whole industry?
I think for middle-sized businesses, yes, because fundamentally, if you are a business now, a medium-sized business that is successful, unless you're hyperscale, you've generally got a monolith, because that's been a really successful architecture for the past 10 years. You know, people have got products out, very solid products out there that are supporting large numbers of users and generating a lot of money. And it's those people who have money who now have a chance to invest it, going over to a microservices model and maybe looking at how to get the next level of scale or the next level of speed.
So it's funny because my favourite management sort of writer was Pete Drucker, and he used to talk about you have to scratch the entrepreneurial itch, but you also have to scratch the itch to conserve. And I think that paradox is where a lot of companies are. All of their cash flows are generated by the monoliths, but they also know that the future is knocking on the door, and in some cases it's already there. And their architectural pattern won't hold in the next 1, 2, or 5 years. And that's, for a lot of companies, they're in that no man's land where they know they need to go, but the risk to their current business is actually unbearable for them.
Yeah, I mean, we've all got burned in the past with big bang changeovers, because sometimes they're hugely risky and they take a long time. The benefit of this cloud native approach is that you can do it iteratively. And I do know people who've rewritten some of their monoliths, but usually not all of their monoliths.
Well, I mean, it's funny you say that it can be done iteratively, but in fact, the success pattern that we've seen is iteratively, right? I don't think we've ever seen Big Bang or Greenfield or anything like that. All right, then. So that brings us then to our third observation, which is that organizations really do favor developer productivity over machine productivity. And this slide yours, Anne.
Oh yeah, this is my slide. Yes, so when I'm going out and talking to non-hyperscale companies, so this is not the people who are actually generally talking at conferences like Google and Netflix. These are more normal folk. Then what you're seeing is that people are very happy to get scale, resilience, cost savings out of cloud native. So the kind of the more famous use cases for cloud native, they're very happy to get that. They're not going to turn that down. But that isn't their prime motivation. What they really want is their development teams to go faster, to release more quickly, not necessarily overall bandwidth wise to release bigger products in less time, but to release more iteratively and get function to market more quickly, so reducing latency if not necessarily increasing bandwidth. And they see the radical decoupling aspects of distributed systems, of microservices, helping them do that. So they care about microservices first, and then containerization and orchestration almost as a second. And the difficulty with this is, as I said earlier, microservices is a car, not a can opener. It's really quite hard to learn, and it's something that is difficult to do iteratively because you need to step back and make actual architectural decisions about what size of microservices you're going to create and how they're going to be divided up. So more decoupling is not necessarily equal to more good when it comes to microservices. It depends where you're breaking up your services. So when you're exchanging messages from one machine to another, that's quite a lengthy process. That's a high latency process that will take 100 or 1,000 times longer than just passing an internal message. So you have to be very careful when you divide up microservices that you don't have sudden latency sensitive messages traveling between your machines, or you might find that the overall performance of your system goes down quite considerably. So at this stage you do need to balance physics, machine productivity with your developer productivity, and think carefully about where your borders lie between your microservices. Another issue that we often see is that everybody goes bananas and creates a completely different microservice that are then very difficult to get talking to one another. So commonality constraints, I know it almost seems like it's the reverse of what we're talking about when we're talking about microservices, but it is incredibly useful. You do need some commonality, and there's some great tools out there for providing that, things like Linkerd, for example. There is lots to learn. This is not something that really should be learned by someone iteratively reading, spending 5 minutes reading something on Stack Overflow, then going away and implementing it. You can do that fine for Docker, absolutely fine for containers, but not for orchestrators unless you're using a managed orchestrator. But even then, that's not ideal, and certainly not for microservices. So iteration is absolutely great, and I love it, and you should definitely be thinking about learning an iteration, but don't fire all your architects quite yet. You still have some thinking for them to do. So Jamie, back to you.
Yeah, it's like the good old-fashioned principles of computer science and distributed systems. They don't go away. There might have been a period where the stuff we learned at university wasn't relevant, but all of a sudden it's relevant again. Speed of networks versus the speed of accessing local memory, etc., etc. And we see regularly schoolboy errors, people making calls to a microservice as if it was in the same process space and then not understanding why they've got performance issues. So I won't dwell too much on this model. Again, it's simply to re-emphasize Anne's last point that companies love rapid development. That may lead them to think about microservices, but that then leads them in turn to think about containers. And it's at the nexus of these three things that companies are really succeeding. And of course, it's natural that they don't care too much about the cloud, but actually they do care a lot about rapid development, and the cloud infrastructure is one way to achieve that. So let's take a case study that tries to pull all of this together. I think this is a good moment for me to mention the handouts. You can see that there's the Container Solutions training portfolio. That's basically in there in case anybody wants to buy anything from us. The models, the cloud native journey are collected in the Container Solutions Discovery PDF. Give that to your managers, please, in case they want to buy something. And the third bit is the Zuva case study, which is the case study I'm going to look at now. So Zuva is a really, really nice company based out of Amsterdam, but same in the whole of the Netherlands. And it's an aggregation site, it's e-commerce, it lets you choose hotels, choose holiday destination, share pictures, share reviews, and it's actually ideally suited to a microservice architecture because each different part of the application can be served by a different service or microservice. And what had happened with Zuva was that they actually bumped into what we're now calling Legacy AWS. And a lot of people are like, wait, what? Legacy AWS? What the fuck is that? Well, Legacy AWS is the stuff you write when you don't know what you're doing, and it's brilliant. It's a supernatural power, going back to our cloud native journey, and it gets you started, and it gets you, it gets you load balanced, and it lets you rapidly deploy and capture large audiences. But you start to realize you've got Legacy AWS when your user base starts to grow and you get your first bill from Amazon for 80 or 90,000 euros for a single month. So Legacy AWS is very common. I also think it's a side effect of companies who are trying to capture markets, and I must say that, I agree with that. I think, if there's a market to be captured, grab the market as quickly as you can and refactor your stuff later. But Legacy AWS is a real problem, and 90% of our clients come to us because they've got themselves in a mess with Amazon. So what happened at Zuva? Well, what we did is we migrated Zuva, we worked with the team at Zuva to migrate them from their hosted AWS setup or their managed AWS setup over to a cluster on Google's container engine that they managed. So the big four features for them was much higher uptime because they were able to take advantage of the high availability features of Google, cost savings, which were significant, but actually not really the main thing, because what they were really interested in was developer velocity. If we take a little step through the technical results now, you start to see how it gets pieced together. So first of all, we have containerized microservices. This is the key differentiator between using a cloud and using a cloud effectively. When your microservices are contained and managed by a single team, you get the management benefits, but once they're containerized and deployed to the cloud, you start to get benefits of the cloud itself. You get auto-scaling, you get load balancing much more easily, and very importantly, you get high utilization of your CPU resource. That means your bill is not going to be 90,000 euros at the end of the month, but it's going to be 9 or 10,000, or much more importantly, it's going to be mapped to the usage of your site. So if you think about Zuva, what they can do is scale up and down based on the demand placed on their system. That means that as their customers use CPU resource, of course, to buy things, that then is reflected in the Google bill. And as people stop using the application, the usage of the cloud comes down. And so there's a mapping between the supply of compute resource and the demand placed on it by the audience. And this is what we call a pay-as-she-goes model. You pay for your cloud as your customer pays you for your services. Another part of the stack at Zuva was the utilization of SaaS offerings. When you move from your own data center to a cloud, when you break up your monolith, move to a microservice, it's always a great opportunity to look at which parts of your software you can retire and which parts of your software you can replace with a SaaS offering. Managing your own software, in this case, Elastic for search and Fastly for caching, can be very expensive. The SaaS alternatives can be much cheaper, and again, the usage is coupled to your customer's usage. Over on the build automation, you see a few interesting features. So monitoring comes out the box because that's part of Google's cloud, Google's container engine, excuse me, and that allows you to monitor the containerized microservices really easily. Again, you see SaaS, Bitbucket and Circle CI for managing the continuous integration and the source code repository. Why would you manage your own Git repo? It's sort of beyond us at Container Solutions. We find hardly any cases where that's a good idea. And it's the same with, why would you manage Jenkins internally when Circle CI offers a perfectly acceptable cloud alternative? Because we're containerizing our microservices, we can take advantage of Google Container Engine's registry management features. And so basically you see through the build process itself and the architecture that we're able to take advantage of the cloud, and this basically leads to a sort of cost-effective and effective use of it. So I think the question for me is, what's really happening here? What's happening in industry that Anne recognised when she was researching the book, and what do we see as engineers and pre-sales engineers with our customers? It sort of comes down to this. The waterfall model was particularly perilous because value was not realised till very late in the project, and risk wasn't reduced until very late in the process. Pre-internet days, that risk was part of the deployment because a product recall for a piece of software literally meant taking cassettes back and sending out new cassettes, or at least sending out physical patches to people. So one of the reasons why the test cycle was so long in the waterfall is because product recall was so expensive. And it's absolutely mind-boggling that the process for shipping physical products, software on CDs, was still in use when we moved into the internet age of software development. Now, of course, all the savvy companies realized this, and they moved to iterative and incremental build cycles where they could release and realize value incrementally, and they could reduce risk incrementally. But if you go back in time, and if you're as old as me, you'll be able to do this, the risk that we were pulling out of these projects was to do with user requirements. We could get the feedback from the customers early, and therefore we could ensure that we were building the right thing. However, getting access to what we used to call web farms, which are basically clusters of computers, was difficult. They were costly, they were guarded, and you couldn't deploy your software onto lifelike infrastructure till the end. And so although the agile methods were good for incrementally creating value and reducing risk, they couldn't pull the infrastructure risk out of the project. This changes with cloud. So if you're using iterative methods, you start to pull user requirement risk out of the project immediately, and if you're using the cloud, you start to rip out infrastructure risk immediately, because you have got access to lifelike production clusters by the very definition of what you're building. And at the end, you simply press a button to say that's no longer test, but it's actually production. And so the risk gets dragged out in your first few iterations. What that actually does is sort of make the infrastructure invisible. I'm sure you'll make a few changes, and it lets the teams focus on microservices or building services as microservices. At the same time, that architectural pattern supports a brilliant managerial pattern. And what that means is microservices teams tend to go a lot faster than iterative teams managed hierarchically. So what's really happening right now is that companies who are succeeding with their migrations are just ripping all the risk out of the projects, and we're finally getting towards this utopia where we're developing against clusters of computers as if we were developing against our BBCs or Commodore 64s when we were all teenagers. We're not there yet, but we are certainly on our way to being there. And the results are staggering. So this is from a similar customer to Zuba. We don't have Zuba's data. I don't think we need to focus on the money. So for a team of 10, we save 40k a month, which compounds to over $500,000 a year. But companies with a $10 million engineering budget don't care about 500K. But they do care about the fact that they used to run the test in 16 hours and now they run them in 1. They also care about the fact that downtime goes down 97% because we're not patching and rebooting servers once or twice a day. I'd just like to point out, for the case we're looking at, this was an AWS to Google migration. So do not think just because you're on AWS, your downtime will go down to 0. It's just another cluster as if you were running the cluster back in your own data center. Environmental changes go down. What that means is the time that we used to spend messing about with failures or reacting to failures or maintaining the system becomes a potential productivity gain of 50K or just under 50K per month. Now, assuming that the people who've got all this extra free time don't spend it Facebooking, that is a ginormous leap in productivity. And that is what customers really value, the 50K they can take or leave. So in conclusion, high quality tooling, which I think we've been waiting for forever, is making it really easy to get started with cloud native. Unfortunately, a management pattern is emerging where, based on proof of concept and extremely limited understanding of distributed systems, management decisions have been taken to transform a whole organization or to build the latest version of some software for a customer using the cloud. I think this would be the definition of batshit crazy for us. You've got experimental tech, you've got a paying customer. This is not the time to experiment, at least not without discussing it with your customer and coming up with a risk-averse way of delivering that software. Even the best teams, the team at Zuva, are awesome, right? Many of our customers are completely awesome, but they're new to the cloud. So even the savviest team make these mistakes. The ones who are succeeding with cloud native, they get to day 2 quickly. They understand that they're in a kerfuffle, they're in a mess, they realize that's happened, and they start to take corrective action. Build automation is completely table stakes. It's non-negotiable. People say to us, oh, we're going to go to microservices in the cloud, and we'll look at the build later. We don't need to look at the build. Keep moving. Nothing to see here. But it's crazy, because unless you've got a fully automated build process, you will never succeed with microservices. So for us, that's completely table stakes. There's no point talking about the utopia of cloud until you confront the fact that your build automation is low, or you have a culture, that doesn't favor automation. That brings us back, oh my God, that model appeared again. I'll have to apologize for that. That brings us back to the end of the webinar, because we don't want to take too much of people's times. And I think we can take some questions if there are any, or some closing remarks from Anne.
Are there any questions?
I've got a question for you, Anne. You referred to the customers and the companies that were succeeding with cloud natives as normal. What were the people like who were working there? Were the teams who had worked together for a long time and were used to solving problems, or were they new teams?
I think that with any difficult thing like this, one thing that came up over and over again was trust, that they all needed to trust one another. So they can't be completely new teams, and there can't be people coming in and out either, because there's so much learning to be done. Even if you use managed orchestrators, and I have to say I'm increasingly of the belief that you should use managed orchestration because it's really quite difficult. Even if you're using that, there's still tons to learn. And so you don't want to be investing all of that education in folk who are just in and out. You do need to have some continuity, and it's all new stuff. So you don't get a massive benefit from just hiring in expertise, because everybody's learning, and it does depend a lot on what your company needs and how your company works and what your internal culture is and how people are being instructed. It's a trust thing. You've got to have trust. Yeah. So you've got to build long-term teams. A
few questions are coming in. Maybe I was going a little bit too quick on the last few slides. The question is, why will we not succeed with microservices if we don't have build automation? Can we please elaborate on that? Do you want to take that one, Anne, or shall I take it?
I can completely concur with it, because everybody I've spoken to has said we had to go back and massively automate to make this work. But you want to talk about the detail of it, Jamie?
Well, I think we can go into a little bit. Well, the question is, why will we not succeed? So, on the one hand, there's our observation that those succeeding with microservices have automated the build. The question is, why do you need to do it? So, in my opinion, this is the reason why. If you want feedback, you want quick feedback. The spirit of agile is to get the latest features back to your users as quickly as possible to capture some feedback. So if you look at it from a business perspective, think of Zuva, for example. Maybe the product owner is watching a documentary and has an idea for a special offer for a holiday in Greece. And the product owner wants to, for example, change some of the imagery on the homepage. He wants to do that quickly and see who is clicking on that link. So he says to the microservice team that are responsible for the front page where the images are dropped, can you please fork the repo, stick some specific images in around Greece, and release it to the north of the Netherlands. And let's see who clicks on it. Do we get a high click rate or a lower click rate? Ideally, that can be done in a day. The idea happens in the evening, the product owner comes in, speaks to the team, they prioritize it, and then they get that feature out. If 1 or even 2 hours are spent manually deploying that microservice, your window of opportunity is gone. And psychologically, that has an effect on how you create. At Container Solutions, we always talk about the creator being close to the created. So if you're an artist and you're making a sculpture, as you mold the clay, you get feedback from tacit feedback, and you see what it is that you're creating. Now it's the same when you're developing. You don't want to have to submit your job to see the results in an hour from now. So when you're building microservices, you need that feedback loop from the business side of things. The other thing is, it's simply impractical. We just finished a job with a customer. They've got hundreds of microservices. If part of the hundreds of microservices, by the way, deployed hundreds of times a day. So each microservice will get deployed once or twice, but maybe 5 or 10 times. So you're well on the way to between 500 and a couple of thousand deployments per day. Any manual steps in that will quickly compound to a loss of productivity and therefore loss of money. So I hope that answers the question for the person asking it. If it doesn't, you can come back to me now in the chat box. Alternatively, we can take this up offline in one of our public Slack channels. And if you don't have anything, okay, this is all here. We have a response from the person we just answered the question for, and he said, perfect, thanks. Maybe he said that to shut me up. I don't know. But thank you anyway. But thank you for a good question. And I think we're done now, so I'm going to close the webinar. There'll be an automated email following up to give people the presentation, the link to the video, and the PDFs. Some of you can also look out for an email from me, a personal email, not a robotic one. I'm always looking for customer insights and stories and anecdotes, and if anybody wants to share those with me, I'd like to take that up offline with you via email. Of course, there's no obligation to chat with me. You can just ignore me, but that's what I'll be doing, so you might see some contact from me in the next few days. Everybody who came to the webinar is still here, so thank you very much for hanging in there with us, and we definitely look forward to seeing you all again. And thank you, Anne.
Thanks very much, everybody.
Cheers. Bye.